Hey guys, I just got a call from John Pork. Hey guys, it's Grizz. I received a call from John Pork. He wasn't too happy about the video that I made last week, and to avoid legal proceedings, we're going to be talking about ham radio and SDR today. So, what is ham radio? Well, ham is actually a derogatory term from the 1900s that comes from the word ham fisting, which would refer to a poor operator. Nowadays, we've come to accept it and use it as a very broad term for the hobby. We've established a couple of scenarios that you might find yourself in to where you need ham, but outside of emergency comms, it is a non-commercial protocol that we use. You would just need your FCC clearance, which would be taking your ham radio test. There is a lot of hobbyists out here that use this, and it is great for communications because it doesn't rely on the internet and all that fun stuff. It breaks down to a couple of different routes. If you're going the traditional ham analog route, it would look something like this. And I'm gonna kind of show you what that would look like using these blocks right here. This block right here will represent your microphone. For the microphone, that's gonna go into a preamp. From the preamp, that's gonna go into your audio filter. From the audio filter, you're gonna go to your compressor. From the compressor, you're gonna go to your oscillator, and then from the oscillator to the modulator. Then, next up on the list, you have your driver amp that would go on, followed up by your power amp, and then from the power amp goes to your low pass filter, and then we'll end this all off with a switch, and that switch would follow into your antenna. After assembling this analog radio, you would have spent a lot of money on purchasing these components. You would have multiple points of failure due to potential errors in installation or just hardware usage over time. And to top everything off, this is only capable of doing ham radio. I don't like wasting time or my money, and I'm going to be following up doing a different route. I'm going to be utilizing SDR. One of my favorite things about SDR is, one moment please. It minimizes the amount of components that have to go into it, slipping down to just a handful of items. Your Hacker F Pro, that would be used for receiving the signals. Your Raspberry Pi, that would be running an operating system that would go to a software platform like GQRX, RTL Angel, or in this case we're using GNU Radio, and using an ADC, an analog to digital converter, which is built into those applications to convert these signals. So, how am I going to butcher this pig? Instead of building out a complicated analog radio, utilizing the SDR, this breaks it down into minimal components needed to achieve a functioning radio. We're going to start off with our Raspberry Pi 5. Our Raspberry Pi 5 is going to be handling our compute and using the software application GNU Radio in order to visualize our transmissions, I guess you could say, or the wavelengths, but at the same time just being able to hear it overall. We're going to be having our Hacker F Pro, that is the hardware side for the actual receiving. That's going to have our antennas go into it, and that's what's going to process our signal when we receive it and also process when we transmit. Our power bank / power dock, that is going to be used for powering all of these components, and then we move into the lower side, which is our signal amplifier, but also to our bandpass filter. The one I selected has both of them on there for the signal amplifier, that is going to strengthen our power that we have for the transmission, making it stronger and clearer. And the bandpass filter is going to help with gatekeeping the normies from what I receive. From there, we go to our antennas. For the antennas, you just want to keep in mind, depending on what you're trying to achieve with your radio, there's different antennas that operate in better ways than a general antenna. So if you're using communications like we are, we're running it from 36 millihertz to 440 millihertz with 2 separate antennas. And then to end everything off, we have the coax cable, and that will be our John Pork build. So, as teased the other day, the first thing we're going to be having for John Pork is our case that it's going to be in. So this is from Harbor Freights. This is an Apache 3800. They are basically on stock at all times. They have smaller form factor ones, but they also have larger form factor ones if you'd like to go a different direction. They are, for the most part, water resistant. I wouldn't necessarily say waterproof. They come padded as well on the inside, so there's multiple different use cases that you can do with them. You know, besides doing the ham radio build like we're doing, you can also store, you know, cameras or computer equipment, things of that nature. So that is the first thing that is going into the John Pork build, is the case itself. Next up, we have our portable display that we're going to be running. This is a 15.9 inch display with touchscreen, and that's how we're going to be able to see everything that we are doing on the system and utilizing the SDR. You're able to get this from Amazon. Next up, from hackerwarehouse.com, we have the Hacker F Pro that we picked up. This is going to be the hardware side of the radio and how we're going to be receiving all of our inputs that we get. On top of that, we have our Raspberry Pi 5 that we're going to be running for the computer side to run the software on it. You're able to get these from Micro Center, or you're able to order them online through Amazon and other various sites. I'm also going to be running an Anchor power dock. So this has 6 ports total. There's 3 type A and 3 type C, with one of the type C's being a 30 watt fast charging port. The reason I chose this is because this will have a higher power consumption compared to my absolute unit setup that I did, and so I need to be able to compensate. Next up, we have our SD card. This is going to be used for holding our operating system for our Raspberry Pi, so we're able to load up GNU Radio and all sorts of fun stuff on it. We also have our SMA connectors. The SMA connectors are going to be used to attach to the HackRF Pro to the antennas that we're going to be running, and those are the cable types that you'd be using. Please keep in mind that we are using reverse polarity SMA connectors. There are different ones, and if you use a non-reverse polarity connector with a reverse polarity connection, it may burn out your board, so please be mindful when purchasing. We also have our antennas. So these antennas are for 120 millihertz to 440 millihertz. These can be purchased off of Amazon. But the antennas, it just depends what you're trying to do when you're operating your radio. So please also take into consideration looking at frequency ranges for when you are building out your project and what you're trying to achieve with it. We will be using some different antennas in the future, but for now, those are the ones that we're running. We also have our GX connectors. This is from Amazon. This is a 40-piece set. This comes with 5, 3, 4, and 2-pin GX connectors, and it comes with the male and female sides. These are going to be used for powering on our device. We will be splicing some cables to run these. The reason I went with GX connectors, as I normally do, is just because of the variety of inputs I can tack them onto for supplying power to my projects. We also have a angled HDMI cable. This is going to help with clearing the tight tolerance between the case and the monitor. And This was from Amazon. And then lastly, we have our amplifier and filter combo. This was also purchased from Amazon. This is going to help with strengthening and making the transmission more clear, and also to at the same time helping with blocking out some of the frequencies that we don't want to pick up and overlap when we're receiving on the project. And there you have it, ladies and gents. This is John Park's build list on the flesh. I am It's Grizz, and I will see you guys on the next one.